everybody, this is a video on what it means to have a solution to a system of equations. So pause this video and write down this topic, an essential question. Then pause this video and write down the question, the solution, and the two equations, and draw a sketch of the graph. Okay, so today we're going to talk about what is a solution to a system of equations. Well, if you think about what a solution is, it's something that makes something work, or in this case, our solutions makes our equations true. So yesterday, you guys did a Desmos activity where you looked at two equations and tried to figure out a pair of numbers that made both equations true. So our solution for these two equations is 10, 2, because when we plug in 10 for x and 2 for y in both equations, we get a true equation. Let me show you what I mean. Let's check this solution in this equation. So instead of x, I'm going to put 10. And instead of y, I'm going to put 2. Equals 12. Well, let's check and see if this is true. 10 plus 2 equals 12. 12 equals 12. That is true. So 10, 2 is a solution for this equation. Let's check our other equation. Instead of x, I'm going to plug in 10 again. Minus, instead of y, I'm going to plug in 2 equals 8. 10 minus 2 is 8, and 8 equals 8. Check. So, the solution to both of these equations at the same time is this point. This is the only point that will make both equations true. This equation here is x minus y equals 8. All of the points on this line, like this point, which is 13, 5, makes this equation true. 13 minus 5 equals 8. Any point on this line makes this equation true. That's how we get those lines. The other equation is x plus y equals 12. All of the points on this line, like 7, 5, make this equation true. 7 plus 5 equals 12. That's why When we graph a system of equations, the point where they cross is the point that makes both equations true. At this point, 10 plus 2 equals 12 and 10 minus 2 equals 8. It makes both equations true. That's why it's our solution. So we have one solution, and that solution is 10, 2. Make sure you have this written down. So there are 3 types of solutions to a system of equations. The first case is when there is only one solution. That's when you have 2 lines that cross each other at only one point. So if they cross at one point, then you only have one solution. Another case is when you have 2 lines that are parallel. So they're side by side. Parallel lines never cross each other. That means that for parallel lines, there is no solution that makes both equations true at the same time. So when you have parallel lines, there is no solution. The last case is when we have one line and our second equation is the same line. So notice these lines are on top of each other. So we would say this is same line. They touch each other then at an infinite number of points. They're always crossing. Each other. Because they're the same line and they're always crossing each other, and they have many, many points, many, many, many solutions, we say that these have infinite solutions. So in this case, when they're the same line, they have infinite solutions. So the 3 cases are, your graph has one solution if they cross at one point, no solution if they're parallel and never cross each other, and infinite solutions if they are the same line, because they're always crossing each other because they're the same line, they're on top of each other. So make sure to write this down in your notebook. So let's look at a couple of examples. Example 1, what is the solution to this system of equations? So in this case, we have two lines that cross each other at one point. That means we have one solution, and the point where they cross is -3, -4. This means if I plug in x equals -3 and y equals -4 into both equations, I should get true equations. So let's try it. Y equals -4, x equals -3, 2 times -3 is -6 plus 2. -6 plus 2 is -4. -4 equals -4. That is true. Let's try the other one. Again, y is -4 equals x is -3 minus 1. -3 minus 1 is -4. So again, true. This is our solution, where those lines cross each other. In this case, what is the solution to the systems of equations? These equations never cross each other. They are parallel lines. Because they are parallel, there is no solution. One thing I want you to notice is in order to be parallel lines, they must have the same slope. Every time the top one goes down 1, goes over 1, 2. Down 1, over 2. Same on the bottom. Down 1, over 2. Down 1, over 2. That's why they'll never cross. They have the same slope, so they're going in the same direction. They're just at different heights. Lastly, what is the solution to this system of equations? Notice we have two lines here, this pink line and this blue line. They are always crossing each other at all these different points. Every single one of these points is a solution, and these lines go on forever. That is why when they are the same line, we say that there are infinite solutions. So again, to summarize, when they cross each other at one point, there's one solution. When they do not cross each other at all and they have the same slope but different heights, there's no solution. And when they are the same line, there are infinite solutions.